What if I told you that we might be on the verge of essentially ending new HIV infections worldwide? Not with a cure, not with a vaccine, but with a drug so effective and convenient that it could change everything we know about HIV prevention. Scientists have just announced results from clinical trials of a medication called Lenacapavir that requires just 2 injections per year and showed 100% effectiveness in preventing HIV infection. Not 95%, not 99%, but literally zero infections in the trial participants who received it. Today, we're diving into what might be one of the most important medical breakthroughs of the decade and why this could finally give us the tool we need to end the HIV epidemic. Let's start with some context because to understand why this is such a big deal, you need to understand where we are with HIV prevention right now. HIV, or human immunodeficiency virus, has been a global health crisis for over 4 decades. Since the epidemic began in the early 1980s, more than 40 million people have died from AIDS-related illnesses. Currently, about 39 million people worldwide are living with HIV, and in 2022 alone, there were roughly 1.3 million new infections and 630,000 AIDS-related deaths. Despite massive progress in treatment and prevention over the past few decades, HIV remains a major global health challenge, particularly in sub-Saharan Africa, where the majority of new infections occur. Now we do have prevention tools already. The most well-known is PrEP, which stands for pre-exposure prophylaxis. PrEP involves taking antiretroviral drugs to prevent HIV infection in people who are at high risk. The most common form is a daily pill called Truvada, which combines two antiretroviral drugs. When taken consistently, it's incredibly effective, reducing the risk of HIV infection by more than 99%. There's also an injectable form called Apretude that's given every 2 months. These are genuinely life-saving medications that have helped reduce HIV transmission in many communities. But here's the problem: adherence. For PrEP to work, you have to take it consistently. With daily pills, that means remembering to take a pill every single day. Studies have shown that in real-world settings, adherence to daily PrEP is often much lower than in clinical trials. People forget doses, they run out of medication, they face stigma when picking up prescriptions, they struggle with side effects, or they simply find it difficult to maintain a daily pill routine. Even the injectable 2-month version requires regular clinic visits, which can be challenging for people with transportation issues, demanding work schedules, or limited access to healthcare. And this is where Lenacapavir enters the picture as a potential game changer. Lenacapavir, which goes by the brand name Sunlenca, was originally developed and approved as a treatment for people already living with HIV who have drug-resistant strains. But researchers at Gilead Sciences, the company that developed it, started investigating whether it could also be used for prevention. The drug has a unique property: it's extremely long-acting. A single injection can maintain protective levels in the body for 6 months. That means just 2 shots per year. No daily pills to remember, no monthly or bi-monthly appointments, just twice yearly injections. The clinical trial results, which were published in 2024, were honestly jaw-dropping. The main trial was called Purpose 1, conducted in South Africa and Uganda, with over 5,000 young women and adolescent girls, a population that faces disproportionately high HIV risk in sub-Saharan Africa. The trial compared Lenacapavir injections every 6 months against daily Truvada and against Descovy, another daily PrEP pill. And the results? In the group receiving Lenacapavir, there were 0 HIV infections, not a single one. By comparison, the daily pill groups had multiple infections, not because the pills don't work, but because real-world adherence isn't perfect. Let me emphasize this because it's absolutely remarkable. 100% efficacy in a real-world trial setting. That almost never happens in medicine. Usually, even the best drugs show some failures in clinical trials. But Lenacapavir, given just twice a year, completely prevented HIV infection in every single person who received it on schedule. This isn't a small sample size either. We're talking about thousands of participants followed for an extended period in settings where HIV transmission rates are high. There was a companion trial called Purpose 2, conducted in Argentina, Brazil, Mexico, Peru, South Africa, Thailand, and the United States, this time focused on cisgender men, transgender women, and non-binary individuals who have sex with men, another population at elevated HIV risk. This trial compared lenacapavir against daily Truvada. Again, the lenacapavir group showed extraordinary effectiveness, with only a tiny handful of infections, all of which occurred either before people received their first dose or when they missed their scheduled injections. Among those who received lenacapavir as scheduled, the protection was effectively complete. So how does lenacapavir actually work? It's a capsid inhibitor, which is a relatively new class of antiretroviral drugs. To understand this, we need to talk briefly about how HIV infects cells. HIV is a retrovirus that targets immune cells, specifically CD4 T cells. When HIV enters a cell, it needs to release its genetic material so it can hijack the cell's machinery to make copies of itself. The viral genetic material is protected inside a protein shell called the capsid. Lenacapavir works by binding to this capsid and stabilizing it in a way that prevents it from properly disassembling. Without being able to release its genetic material, the virus can't replicate. It's essentially trapped and rendered harmless. What makes lenacapavir special isn't just how it works, but its pharmacokinetic properties, basically how it behaves in the body. The drug is formulated in a way that allows it to be slowly released from the injection site over many months, maintaining consistent protective levels in the bloodstream. This is pharmaceutical engineering at its finest. Creating a drug that stays at effective levels for 6 months without accumulating to toxic levels or dropping below protective thresholds is incredibly challenging. Gilead spent years developing and testing this formulation to get it right. The implications of this breakthrough are staggering. First, let's talk about adherence. The biggest barrier to effective HIV prevention with current PrEP methods is the challenge of daily pills or frequent clinic visits. Lenacapavir essentially removes that barrier. 2 appointments per year is manageable for almost everyone. You don't need to remember daily pills. You don't need to worry about hiding pill bottles or facing stigma at pharmacies. You don't need to plan ahead when traveling. You just show up twice a year, get your injection, and you're protected. This could be particularly transformative for young people who often face the greatest challenges with daily medication adherence. The Purpose 1 trial specifically focused on adolescent girls and young women in sub-Saharan Africa because this demographic has some of the highest HIV infection rates globally. In countries like South Africa, Mozambique, and Lesotho, HIV prevalence among young women is several times higher than among young men of the same age. This disparity is driven by a complex mix of factors, including gender inequality, economic vulnerability, age-disparate relationships, and limited power in sexual negotiation. A prevention method that doesn't require daily pills or partner cooperation could be genuinely life-changing for these young women. There's also enormous potential in terms of global public health. The WHO and UNAIDS have set ambitious goals to end AIDS as a public health threat by 2030. That doesn't mean eradicating HIV entirely, but it means reducing new infections and AIDS-related deaths to levels where HIV is no longer a major threat to communities. To achieve this, we need to dramatically reduce new infections, and that requires getting effective prevention tools to the people who need them most. Lenacapavir, with its twice-yearly dosing and near-perfect effectiveness, could be the tool that finally makes these goals achievable. However, and this is crucial, there's a major challenge that could prevent lenacapavir from reaching its potential: cost and access. In the United States and other high-income countries, Gilead is pricing lenacapavir for treatment at around $42,000 per year. Now, for prevention, the price might be different, and there could be negotiations with insurers and government programs. But even at a significantly reduced price, this would be far too expensive for widespread use in low- and middle-income countries where the HIV burden is greatest. This is where things get complicated and frankly a bit frustrating. Studies have shown that lenacapavir can be manufactured for as little as $40 per year per person. Yes, you read that right. $40, not $40,000. The high price in wealthy countries reflects not just manufacturing costs, but also research and development expenses, profit margins, and what pharmaceutical companies call value-based pricing. charging based on how much value the drug provides rather than how much it costs to make. But this creates a massive access gap. The people who need this drug most, young women in sub-Saharan Africa, marginalized communities with limited healthcare access, are the least able to afford it at high prices. There is some good news on this front. Gilead has announced voluntary licensing agreements with several generic manufacturers, which would allow them to produce and sell low-cost versions of Lenacapavir in certain countries. This is similar to what happened with HIV treatment drugs, where generic competition brought prices down dramatically in low-income countries. But the details matter enormously. Which countries are included in the licensing agreements? How quickly can generic manufacturers scale up production? Will there be enough supply to meet demand? These questions are still being worked out, and advocacy groups are pushing hard to ensure that access doesn't lag behind the science. Let's talk about what widespread adoption of lenacapavir for prevention could actually look like in practice. Imagine a teenage girl in South Africa. Instead of needing to take a daily pill, hide it from disapproving family members, or worry about her partner finding out she's on PrEP, she could go to a clinic twice a year, receive an injection, and be protected. The injection could be integrated into existing health services, maybe given at the same visit where she receives contraception or other preventive care. The simplicity of twice-yearly dosing makes it feasible to integrate HIV prevention into routine healthcare in a way that daily pills never quite achieved. Or consider a transgender woman in Brazil who faces discrimination in healthcare settings and finds it difficult to access consistent care. 2 appointments per year is a much lower barrier than monthly or daily medication pickups. It reduces the number of potentially stigmatizing healthcare interactions while still providing complete protection. For communities that face healthcare discrimination, reducing the frequency of necessary interactions can be crucial for improving uptake of prevention services. There's also potential for creative implementation strategies. Mobile clinics could travel to underserved areas twice a year offering lenacapavir injections. Community organizations could organize injection events, making it a social activity rather than a medicalized one. Schools and universities could offer injections as part of student health services. The possibilities are really exciting when you think about a prevention method that doesn't require complex daily routines. But we also need to be realistic about challenges beyond just cost. Implementing any new medical intervention at scale is complex. Healthcare systems need to be prepared to store and administer the injections. Staff need to be trained. Supply chains need to be established. There needs to be community education so people understand this new option and how it works. And there needs to be monitoring and follow-up to ensure people return for their 6-month doses and to track any adverse events or emerging issues. Speaking of adverse events, let's talk about safety. In the clinical trials, lenacapavir was generally well tolerated. The most common side effects were injection site reactions, some pain, swelling, or redness where the injection was given. These were usually mild and temporary. Some people experienced nausea, headache, or fatigue, but serious adverse events were rare. The safety profile looks quite good, especially compared to the alternative of HIV infection, which requires lifelong treatment and carries significant health risks even when well controlled. There are also some important considerations around HIV testing. Before starting PrEP with lenacapavir, people need to be tested to confirm they're HIV negative. This is crucial because giving lenacapavir to someone who's already HIV positive but doesn't know, it could lead to drug resistance. HIV is very good at mutating, and if exposed to a single drug like lenacapavir alone, it can quickly develop resistance. That's why treatment for HIV typically uses a combination of multiple drugs. So any PrEP program needs to include robust HIV testing at the start and at each follow-up visit. Now let's address a concern that always comes up with effective prevention tools. Risk compensation. This is the idea that when people feel protected from one risk, they might engage in riskier behavior in other ways. Some worry that people on PrEP might stop using condoms, potentially increasing their risk of other sexually transmitted infections. This is a legitimate concern, but research on existing PrEP has shown that while condom use does sometimes decrease, the overall benefit of preventing HIV far outweighs any increase in other STIs, which are generally treatable. Plus, PrEP programs typically include comprehensive sexual health services, including testing and treatment for other infections. There's also an important conversation to be had about how lenacapavir fits into broader HIV prevention efforts. This isn't a silver bullet that will solve everything on its own. Comprehensive HIV prevention requires multiple approaches: PrEP for those at high risk, treatment for people living with HIV, which also prevents transmission, condoms, harm reduction services for people who inject drugs, addressing social and structural drivers of HIV, like poverty and gender inequality, and comprehensive sex education. Lenacapavir is an incredibly powerful new tool, but it works best as part of a comprehensive toolkit. The timing of this breakthrough is particularly poignant. We've been dealing with HIV for over 40 years now. An entire generation has grown up in a world where HIV was a death sentence, then became a manageable chronic condition, and now might become a preventable infection. Many people who lived through the darkest days of the AIDS crisis, who lost friends and loved ones, who fought for research funding and healthcare access, are still here to see this moment. It's important to honor that history and remember that scientific breakthroughs don't happen in a vacuum. They're built on decades of activism, research, and the experiences of millions of people affected by HIV. Looking forward, there are already discussions about what comes after lenacapavir. Could we develop even longer-acting prevention methods? Some researchers are exploring yearly injections or even implants that could last multiple years. Others are working on broadly neutralizing antibodies that might provide protection for extended periods. There's also ongoing work on HIV vaccines, which remain the holy grail of prevention. A vaccine would be the ultimate solution, but after decades of research, an effective vaccine remains elusive. In the meantime, tools like lenacapavir represent our best hope for dramatically reducing new infections. There's also interesting potential for using lenacapavir in other contexts. Some researchers are exploring whether it could be used as post-exposure prophylaxis, given after a potential HIV exposure to prevent infection. Others are looking at whether it could be used during pregnancy to prevent mother-to-child transmission, and there's investigation into whether it might have applications beyond HIV, since capsid inhibitors could potentially work against other viruses that use similar mechanisms. The regulatory pathway forward is also important to watch. Lenacapavir is already approved for HIV treatment in many countries. For prevention, the approval process is separate and ongoing. Gilead submitted applications to regulatory agencies in 2024, and decisions are expected in 2025. Meanwhile, countries around the world will need to make decisions about whether to include lenacapavir in their national HIV prevention programs, how to fund it, and how to distribute it. These policy decisions will be just as important as the science in determining whether lenacapavir fulfills its potential. We should also think about the broader implications of this kind of pharmaceutical innovation. The development of lenacapavir shows what's possible when we invest in understanding disease mechanisms at a fundamental level and apply sophisticated pharmaceutical engineering to create new kinds of drugs. The capsid inhibitor approach is relatively new, and lenacapavir's long-acting formulation required years of development. This kind of innovation doesn't happen by accident. It requires sustained investment in basic research, drug development infrastructure, and clinical trials. It's a reminder of why funding for medical research matters so much. At the same time, the lenacapavir story highlights persistent challenges in how we translate scientific breakthroughs into global health benefits. We have this incredibly effective prevention tool, but ensuring that everyone who needs it can access it requires solving complex problems around pricing, manufacturing, distribution, and healthcare delivery. It requires political will, funding, and coordination across governments, pharmaceutical companies, international organizations, and community groups. The science is only part of the equation. There's something deeply hopeful about this moment, though. For decades, HIV prevention required people to make difficult choices and take consistent action, using condoms every time, taking pills every day, managing stigma and disclosure. Lenacapavir doesn't eliminate all those challenges, but it dramatically simplifies them. 2 injections per year is something most people can manage. The 100% effectiveness in trials means that when people do get those injections, They can have genuine confidence in their protection. That confidence matters. It allows people to live without the constant anxiety of potential infection. It allows them to make choices about their relationships and sexuality without fear being the dominant factor. So where do we go from here? The next few years will be critical. Regulatory approvals, pricing negotiations, manufacturing scale-up, healthcare system preparation, community education, all of these pieces need to come together. Advocacy groups are already mobilizing to push for rapid access and affordable pricing. Researchers are planning implementation science studies to figure out the most effective ways to deliver lenacapavir in different settings. Healthcare providers are preparing to integrate this new option into their prevention services. If we get this right, if we can make lenacapavir widely available at affordable prices, if we can integrate it effectively into healthcare systems, if we can reach the people who need it most, we really could see a dramatic reduction in new HIV infections over the next decade. Not everywhere all at once, but in enough places and among enough populations to bend the curve of the epidemic. Combined with continued progress in HIV treatment and other prevention methods, we might actually achieve those ambitious 2030 goals. So the next time you hear statistics about HIV infections, remember that we now have a tool that could change those numbers dramatically. A twice-yearly injection that provides complete protection isn't science fiction, it's science fact, proven in rigorous clinical trials with thousands of participants. The question now isn't whether lenacapavir can prevent HIV. We know it can. The question is whether we, as a global community, will do what's necessary to ensure that everyone who needs this protection can access it, regardless of where they live or how much money they have.